Before we play around with the PWM, let's just see if we can write a program to make the car, say, go in a circle or go in a square or rectangle. So that could be as simple as starting out all stopped with all zeros, and then we drive forward for a certain period of time, maybe a half a second, and then we turn right, and we'll have to try to figure out how much time it takes to do a right turn at this speed. Let's say that's 250 milliseconds. We'll just start with that and try it. So we have 500 milliseconds. Turn both these on, 250 milliseconds. Go forward again, 500 milliseconds. Turn this on again, 250 milliseconds. And we do that 4 times. And if we have the timing right, we should make a square or a circle. So now how do we do that? So obviously there's one way you could do it in software. You could come in here and you could say go forward 500 milliseconds, turn right, 250 milliseconds, blah blah blah. But we don't need to do that in software. We can actually do that in hardware. If you think about it, writing those commands in here in software mainly just goes and sets up the hardware to do what you're trying to do. So why go through this exercise twice? Let's go straight to the hardware and do it there. So basically this is really just a very simple state machine. If you think about it, we come in, everything's 0, and then we put this high for a period of time, blah blah blah. So that's a very simple state machine. And in hardware you can implement state machines in what's called a lookup table. So we're going to do this using a lookup table, otherwise known as LUT. And so here we go. Here's our lookup table. And you can see in this case your default lookup table has 2 inputs and 2 outputs. But we know that we're going to need 4 outputs. So we can just double click and change the number of outputs to 4 and say OK, and voila. This is the miracle of the PSoC, Cypress PSoC hardware. It's highly configurable, and then you just do this interactively, graphically, and then their code, free integrated development environment, figures it all out and does it all for you. Magic behind the scenes. Now, so we know that we have these 4 outputs, and we have 2 inputs. So with 2 inputs, that means we can have 4 states. But we really have more than 4 states. We have the off state, and then we have the going forward state, and then we have the going forward and turning right state, and then we want that to repeat. So there are 3 unique states, but when you consider that we want to do this 4 times, we now have 4 forward outs and 4 right and forwards. And so that's 8, and we have the stopped state, so that's 9. So we only have options for 4 here, but we really need more than that, and we actually need more than 8. So I'm going to say we're going to have 16. And so for 16 states, we're going to need 4 input pins. So let me make this bigger here. So now you can see we have 4 input pins and we have 4 output pins. And with those 4 input pins we have 16 possible combinations. And it looks like the system somehow put in some 1s and 0s for out 0, so we're going to click on clear all and clear that.